Today, we're going to be taking a look at table question answering, which is essentially if you could ask a Excel sheet a question like, what is the GDP across both China and Indonesia? And it would be able to look at the table, identify the two parts of the table that are relevant to that question, sum those both together, and return you that answer. But imagine we take that and we apply it not to just one table in Excel, but we apply it to millions or even billions of tables, and the system is actually capable of taking our question, retrieving the correct table to answer that question, and then repeating the process I just mentioned before, where it extracts the specific parts of the table that are relevant to our query, and even performs operations like summing over those values or averaging over those values. That is what we're going to learn about in this video. So let me just describe the process that we're going to be taking in order to implement this. We're going to start with a vector database here. Naturally, we'll be using Pinecone for that. Then what we do is we add something called a retrieval model. Now this retrieval model, it will be an MPNet model. So typically with natural language, semantic search, MPNet is a really good option. But this MPNet model has been trained for table or reading tables. So this is our retrieval model. Now, what's going to happen is we're going to ask a question like the question I mentioned before. So something like, what is GDP across certain conditions? Right, so we're going to ask that sort of question. We're going to take that, it's going to go into this retrieval model, which is our MPNet table retrieval model, and it's going to encode that text into a vector. And that vector represents the meaning behind that question. So that MPNet encoded vector goes into our vector database. Our vector database then returns relevant tables, which have also been encoded by that MPNet table model, and it returns them to our next model, which is going to be a table reader model. It's going to be a table reader. Now, this table reader model is also going to read our question from up here. So it's going to see both of those. It's going to see what we've returned from Pinecone over here, and also our question. And for the table reader, we're going to be using a model called TAPAS. Now, what TAPAS can do is what I mentioned before, where we take a table, essentially, and it's going to identify the parts of that table that answer our particular question, and it's going to also say whether we need to sum over those parts, whether we need to average, or whether we don't even need to do anything, whether just the value itself is relevant and answers our question. So that's the system we're going to be building. Let's move on to the code and we'll start putting that all together. Okay, so we're going to be running through this table question answering document example from Pinecone, so you can find that. Docs, pinecone.io/docs, table QA. And then what I'm going to be doing is just going through the Colab, so you can just click on opening Colab and run through the exact same code that I'm going to be going through. So that will open this Colab notebook here. This is another really cool idea and example notebook from Ashok, so again, thank you for that. Now, the first thing we want to do is come up to runtime, go to change runtime type and switch this, or make sure this is on GPU. If it is not, that will just make things a lot faster later on. There are a few prerequisites that we need to install. Torch scatter might take a little bit of time, so if it is taking some time to install everything, that is the reason why. I'm not going to rerun that because I have already done it. And then what we want to do is we need to initialize this notebook here. And this is just from the Hugging Face Datasets Hub. Ashok has uploaded it. It is a subset of the open table and text question answering dataset, which is just a load of text and tables from Wikipedia. Now, once that has downloaded, we'll see that we have a few features of URL. So where is it from? Title, headers, which is literally the headers of the table, and then data within that table. So we can have a look at one of those. Now the bits that we are most interested in is here. So the headers, so this is about American football, no, baseball, I think. One of those things, I'm not sure. And you have your headers here, level, team, league, manager, and then you have the data. So in level, you would have AAA, AA, A, and rookie, and then so on with the other bits of data in there as well. Now, what we can do is we can format all of those into pandas data frames, which just makes things a lot easier for us in both reading and later formatting. So let's go ahead and do that. This again might take a moment to run. Okay, 14 seconds. And then we can run this and we can have a look at what I just showed you, set from in table format. So now we can see it's a lot easier to read, nice formatting. So great. Now what I want to do is move on to that retriever. So remember in that visual before, we had the Pinecone vector database, which led into the MPNet Table retriever model. We're going to go ahead and initialize all of that. So the retriever, we're going to be using a DeepSet all MPNet-based V2 table model. So we execute that. As I said, this model has been fine-tuned specifically on retrieving and embedding table-like data and matching those up to natural language queries. Now, once that has downloaded, we'll see this kind of explainer or summary of the model. So we have the MPNet transformer model, it's been fine-tuned specifically for this. We have the pooling method. It is using mean pooling, you can see that there, and there's a normalization after. So because it has that normalization, that means we can use both cosine similarity, which we can use if there is normalization or not, and we can also use dot product similarity because we have that normalization component. Now, this retriever does expect tables to be in a particular format, so we need to initialize this, and let's have a look at what that format actually looks like. So we are going to have something like this. So looking again at that same table, at the top here we have the headers, and then we have a new line character. Okay, and then we have the next row of the table. All these are separated by commas, as you can see, and then we have a new line again. So essentially we're just reformatting it into a comma-separated file format. Now, the next thing we want to do is initialize our Pinecone vector database. For that, we need an API key, which is free, and we can get it from either this link here if you're in the notebook, or if not, we just head on over to app.pinecone.io. This will either lead you to a sign up or sign in page, or it would lead to this if you've already signed up. And what you need to do is head over to your default project or any other project if you have other projects in there. You go over to API keys, go to default here, and you want to copy this. And then you need to just paste it into here. Now, I have pasted mine into a variable called API key, so I can add that in there, run this, and that just initializes our connection to Pinecone. From there, what we need to do is create a new vector index where we're going to store all of these formatted table objects, but after they've been encoded by our retriever model. So I'm going to call my index table QA. I'm going to use cosine here, although like I said before, we can also use dot product similarity. Dimensionality, this just aligns with the model, so we can actually see that if we do model.get sentence embedding dimension or retriever. Okay, and then we get this 768. So we could also put that in here if you wanted. So rather than hard coding it, you can just do this. And yeah, we run that. For me, I've already created this index, so that will happen really quickly. if you haven't created the index, that will probably take like 10, 15 seconds to run. Then what we want to do is we're essentially going to go through our entire data set. In batches of 64, we are going to get our process tables. We're going to then encode them using our retrieval model. And the output of that we need to convert into a list for Pinecone. We're going to create a set of unique IDs. Now this is just a count. If you prefer, you can use something else, but this works for this example. So leave it with that. We add all of those into what we call an upsert list. So we're just going to pass the IDs and embeddings. We could also, if you wanted to store, we're going to store the tables locally, but you could also store the plain text version of the tables in a metadata dictionary and upload those. But we're not going to do that. We're just going to use the local ones for the sake of simplicity. And then what we want to do is just upsert all these into Pinecone. We would run that. That will take a little bit of time. I don't think too long, maybe 6 or 7 minutes on Colab. But I have already run it, so okay, I can see it's working again here. So now I'm just going to stop it because all of these have already been uploaded into my vector index. Now what we're going to do is begin asking questions. So this is not the full, what we're doing right now. We have the vector database and we have the retriever. We don't have the later table reader, and we're going to implement that in a moment. But for now, I just want to see, is it going to return the correct table for us? So we're going to say, what was the GDP of China in 2020? We're going to encode that using the retriever to create our query vector. And then we're going to pass that to Pinecone. And we're just going to return the top table. We could return several tables if we wanted, return 100 if you wanted, but we're just going to be applying the reader to a single table, so I'm going to go with that for now. Okay, and you see that we get this ID here. Now this ID is, like I said, it is a count that we created earlier, so we can actually use that value in order to extract from our tables that we created earlier, the tables variable. We can just extract that specific item. And you can see that it does seem to give us a pretty relevant table. So right at the top here we have China, and we have there millions of USD in GDP and the year as well, which is 2020. So that looks pretty accurate. Okay, so we've retrieved the correct table. Now what we need to do is extract that specific piece of information using our table reader model. Now, for the table reader model, we're going to be using a TAPAS model that has been fine-tuned for this specific task. And to do that, we need this. So we are going to use a model name, Google TAPAS base fine-tuned WTQ. And we're going to be using the Hugging Face Transformers library, and we need to initialize a TAPAS tokenizer, which is going to convert our natural language query and the tables themselves into tokens or token IDs. They get passed into this TAPAS for question answering, which is a TAPAS transform model followed by a question answering head. And it will basically go through all those, and it will identify the specific part of the table that answers our question. And it can also do things like say whether we need to sum certain values within that table, or whether we need to average them, or do all these different operations, which is pretty impressive in my opinion at least. So we're going to package all of that up into this pipeline here, which is a table question answering pipeline, and it would just include our model and the tokenizer. We run that, and then what we can do is we'll pass the table that we retrieved. Okay, so the China GDP table, we pass that, and we also pass our query, which is what is the GDP of China in 2020. Okay, and run that. Okay, cool. So you see that it wants us to take the average over one cell. Okay, so it is correct. We should just take the average over this one cell because that is our answer. So the 27.8 million, I think it is, in USD. So if we come up here, we can see it right there. Okay, so that is our answer. Now what I want to do is I want to ask more questions. Okay, I'm going to ask more questions, but I want to do it a lot more efficiently than writing all of that code out again. So I'm just going to create a few functions here that will help us. So query Pinecone, which is going to retrieve the relevant information and then match that up to a particular table, return that to us. And then we want this, which is just get the answer from the table, and that is just going to feed everything into our pipe and return those answers. Okay, so for this first question, I'm saying which car manufacturers produce cars with a top speed of above 108 kilometers per hour. Now, you can see that this is, again, a super relevant table, and this is already, at least for me, impressive in itself that it's managing to get this. And we can see max weight, okay, 220, 190, 185, 186. So there's 4 manufacturers there that do that. That is Fiat, Bugatti, Benz, and Miller. So we come down here and we're going to do get answer from table. And we get this. So Fiat, Bugatti, Benz, and Miller is our answer. There's no aggregator, this is text, so it's saying, okay, you don't need to average or do anything here. These are just the answers. Okay, let's do another one. Which scientist is known for improving the steam engine? Okay, and we can see in this table, if we have a look here, for improving the steam engine, so we should expect the answer to be George Henry Corliss. Let's get the answer from the table. George Henry Corliss. Pretty cool. Let's do another one, another kind of simple query, and then we'll move on to more advanced queries. So what is the Maldivian island name for Oblu Select at Sangeli Resort? Okay, and we can see Oblu Select at Sangeli, and we have Akiri Fushi. It's probably a terrible pronunciation. I'm very sorry to any Maldivians watching this. And yeah, we get the right answer, of course. So that in itself is already really impressive, but it actually doesn't stop there. It gets even more insane than this. We can start asking really more complex questions that take sort of more than one step for this model to figure out. So I want to say, what was the total GDP of China and Indonesia in 2020? Okay, let's query. We should get the same table that we got before. Yes, we do. And then we want to get the answer from this table. And we get this. So we get this aggregator, sum, so it's telling us the sum. These 2 values here. Okay, so the 27.8 million and 3.8 million. And you can see here that this is correct. Right, so we could just maybe add a little bit of a wrapper function that consumes different types of aggregators, like sum or average, and just handles that little bit of logic at the end there. And we have our answer, which is insane. So that is, that's another thing, really, really impressive. And it's not just sum. We actually kind of saw this earlier, although it wasn't used in the right way. But let's have a look at this. What is the average carbon emission of power stations in Australia, Canada, and Germany? Okay, let's take a look. Okay, looks pretty accurate. Although this is just sort of like a random selection of different power stations in these different countries, so it's not perfect, but nonetheless, we can go with this. And then we can see, okay, we have an aggregator average, and we need to average over these values here. So number 1 is not being very good. Who is that? Australia? Yeah, very bad. But that is really impressive, at least to me. I was pretty blown away with this example. So that's it for this video. I hope this has been interesting and useful. It definitely is for me. I'm really enjoying seeing how we can actually apply question answering to tables, and even more so with the little aggregations at the end. Very little feature, but I think makes a pretty big difference. So thank you very much for watching the video. I hope it has been useful, and I will see you again in the next one. Bye.